Hello guys, and welcome to another video of the series of data structures and algorithms. Today I would like to implement a hash map, or a linked list hash map that is using chaining method. I'm going to explain basically all this. So here's basically what I had. I have this structure right here, this directory structure, because I've been working on this for the past 3 or 4 hours, I think. And or actually more than 4 hours. But basically, I understood the logic and I wanted to implement this logic, but it took me some time to get my code straight, because I already had like this code here. As you can see, this is a huge piece of code, and this has been my workings with linked lists. And basically, if you do not know what a hash map is, if you know Python's dictionaries, this is basically what a hash map is. If you know PHP's associative arrays, so basically what it is something like an array, but instead of storing things in indexes or indices, I don't know how to say that, but in order for you to store these things, you are completely free to choose the kind of key that you would store things in. By default, the C programming language doesn't provide this kind of data structure, as far as I know. And in order for you to do that, in order for you to use this data structure, you're going to need to implement it yourself, which is what we're going to do today. So, first of all, I have this data structure, this file structure here, or directory structure, and I have here a simple logic. So basically, you have, this is an array, a normal array, okay? And each array, what you're going to need to do is, and I'm going to explain this, you're going to need a hash function, and hash function has nothing to do with turning a string into a hash, like when you're hashing a function, when you're hashing a password, for example. No, it's not that, okay? But basically what it does is that it takes a big number and it breaks it down to a limited number, a very small number. However, there is going to be a problem with this. As you can see here in this logic, you would find that there is an array, which is a very normal array, and there is going to be in this array there is going to be, say I have this pair here, 21 and data. So I want to keep data, which is some kind of, I don't know, maybe a name of someone, okay? And I want to store that to 21. So whenever I say 21, I would call data. Now, you know, the implementation of this could be very, very huge, because I could take the representation of a string, for example, the numeric representation of a string, because, you know, in C, a character is basically just an integer at its core. And so I could take these and I could turn them into numbers, which means that this key here, well, it might not be an integer. It could have been a string, and then we took the integer representation of that, and then we would take these and we pass it to a hash map. I'm sorry, a hashing function, and this hashing function would map it to a certain index of the array, and then in this array, I'm going to keep here a header, not a header, well, a head pointer, okay, to a linked list. And as you can see here, this is a linked list, and it ends with a null, as you can see here. And basically, this is what we're going to have to do. So this one of these things, one of these units, is called a node, and a node is basically just three things. It's the key, the value, and the pointer to the next node. And the final node would have the null, you know, the next of that node, the p next. It's a pointer to another node that's basically initialized to be null. And basically, this is exactly what the logic is. So what we're going to implement is this whole data structure today. So I have here a txt file, which is right here. Now, this is going to be the implementation steps. So I'm going to say implementation steps. Now, step number 1, I'm going to need to define the node structure, okay, to have a key, a value, and a p next, or yeah, this way. Now this p next is basically a pointer to another node, okay. The second thing that I'm going to need is that I'm going to need to create a hash function, which is basically going to take a huge number, and it's going to take a limit size, which is basically equal to the size of the array, okay? And it's going to give me a number, or basically it's going to give me an index, and I'm going to be able to have this node inserted at this index, okay? The last thing is I'm going to need a clash or a collision resolution policy. Now we're going to use the chaining method of building this data structure. Okay, there are two methods. There's one called chaining, and the other is called, I think, open or exposed addressing. I haven't actually studied that yet, but we're gonna get to that into in a different video. So basically, this is a very important thing that I want to explain today. So the first thing that I need to do is, well, defining the structure is so simple. So let's say I have defined the structure, but now how to manipulate this structure? So I'm going to need a set of functions. Now, because C is a functional programming or a structural programming language, it's not functional programming language, it's a structural programming language. It's not object-oriented or procedural or whatever. It's a structured programming language. We're going to have some functions to manipulate those data structures, and the first thing is I'm going to need to create a node. I'm going to need a function that can insert the node, and hopefully this insertion is sorted, okay? So there could be an insertion sort or a heap sort or whatever. I'm going to need to find a node. I'm going to need, and by the way, the insertion, it overrides pre-existing keys. This is very important, okay? I'm going to need to find a node, and I'm going to need to delete a node. Now, I think these are all the CRUD. So, create, read, insert, or, yeah, that's the way. And basically, the insertion is basically just a new creation. The find is going to be the reading, the deletion is going to be the deletion. Now, the update is going to be basically the overriding. This is the update part of it. Okay, so this could be the update part of it, because let's say that I have something with the key 12 and it is foo, okay, and then I'm trying to insert another node which has the key 12 but it is with a bar, so the value is bar. So basically it's gonna look for something that has a 12. If it finds it, it's okay, it's going to change this so it becomes bar, and if it doesn't find it, it's just going to insert bar after foo. So if I'm for example, if this is foo and the key is 12 and I'm inserting bar but the key is 13, so it's going to try to find 13, and of course 12 is not 13, so eventually it's going to have to insert the 13 with the bar, whether after or before, but actually it's going to be after, because the 13 as a key is bigger than the 12, and this is a very important thing, because of course finding sorted data is much faster than finding non-sorted data. So this is basically going to be how I'm going to do these things. Now, about these functions, I'm not going to implement them from scratch, because right here, I think right here, I have all those functions implemented on a linked list, which is what I'm going to need to use. However, all these functions are implemented on linked lists that just have a data member and a pnext member. It doesn't have a key and value member. So the structure, or the way the structure is going to be defined, and the way those functions are going to be working with the structure is going to be a little bit different. So what I thought of is that I'm going to just copy the functions that I already have created and heavily tested when I was working on linked lists. Okay, so right here I would have, like, just to make you take a look at how this works, or how many functions I've created. Those are the headers of all the functions that I've created, which is about I don't know, 24 functions. So there is about 24 functions. Not really sure. I think it's 24. And basically those functions have been created just to manipulate data structures, a linked list data structure. But there is only one limitation to this set of functions. It works with the node that has a data member, just a data member, and a p-next, just a pointer to the next node. However, for the logic of a linked list, sorry, not for the logic of linked list, for the logic of a hash map, I'm going to need to have a key and to have a value, which means that all these are going to be, well, I'm not going to need to use all these. I might use, there is a function which is called ordered insert here that uses the insertion sort algorithm at ordering, okay? I'm going to need to use the delete function. I'm going to need to use the find, which is right here. And for the insertion, the ordered insertion, I think I can extend its logic a little bit. So, excuse me. So it would override my my key. Okay, so I'm sorry, it would override my value and doesn't just insert a new node with the same key but with different value. And this could be a clash in the logic because it's a bug basically, which is a bug that could actually be achieved in code. So it's something that is potential at the beginning of implementing this this logic. So the first step that I would do is to try to extend, well, take those codes and try to refactor this structure. Okay, so the refactoring of this structure is basically simple. I don't need all these, so the first part, let's just talk about the first part. I have changed the node structure, so this is the structure of the node. It's going to be taking a key, which is a string, and a value, which is a string, and a p-next. So this is done. First step is done. So let me just come back to the implementation, and I would say that defining the structure, this is done. Okay, that's good. Now the next step is I need to take the hash function. I think the hash function has already been created because I created here a hash function that takes the length, which means how much is the size, or how big is the array against which you are trying to insert the various key value pairs, and the input is basically just going to be the key. Okay, so you're going to take the key, put it right here. You're going to get the size. It's going to get the modulo of the input with the size. So it's input modulo length, and it's going to return that in a red val, and the red val is basically going to be returned in order for me to traverse the array and try to find this a node with this key. So this is the first basic logic. So the second thing is done as well. Good. Okay. Now the third thing is the collision resolution policy, which is going to be very simple. On insertion, basically on insertion, I will check when I am inserting if the key already exists. Okay, so if the key already exists, I'm basically going to override the value, but the collision resolution policy is not targeting this question. Actually, it's targeting another question. Say that I have two keys and they pass on the hash function. I pass them to the hash function, but the hash function actually produces the same result, which means both of these have to be inserted in the same slot, in the same index of the array. So what would I do? What is it that I could do basically? What I could do is solve this problem using the insertion algorithm, the insertion sort, and this is the chaining method. So I'm using the chaining method, and I've basically explained this chaining method. So basically, in this example here, somehow if you have 21 modulo 5, it's going to give you 1. Okay, so I'm going to come to 1 and I'll say, hey 1, I want you to insert a data that has a key of 21 with a value of data, some data, and a null pointer, because this node on insertion, it didn't have this this thing after it, right? So basically I just inserted that 21, and then at some point I wanted to insert something with the key 31. So I passed this 31 to the hash function, and it gave me the 1. So this is a clash. The 1 already is taken. It's taken already by this node. So what am I going to do? So what I'm going to do is very simple. I'm going to use the insertion function that I'm going to make, the ordered insertion. It's going to check here, this 21 is bigger or smaller than my 31, and it's going to insert it in the ordered way. So actually, believe it or not, even if the 31, this node was inserted before this one, and then I wanted to insert this one, the 21, basically they would have had the same order. This order would have been the same thing, and it would be sustained across the additions, the various additions of various other nodes that could map to the index 1 thanks to the hash function. So basically this is the same logic that I would follow in implementation, and this is called the chaining because I'm creating a chain of nodes that basically originate from the same index thanks to the hash function. And this is a way to resolve collisions that could come up from hashing. And again, I would like to say that hashing has nothing to do with hashing passwords. If you come from a security or cybersecurity or a web development background, then you would know that there is hashing, which turns the plain text into some kind of gibberish or gibberish. I don't know how to say it. I think it's gibberish. So it turns it into gibberish, and you don't know what it is, and you cannot decode it, or because it's not encrypted and you can decrypt it. No, it's just hashed. The only way to do that, or to understand what it is to get a potential suspect or a potential candidate and hash it using the same algorithm, and hopefully if the hashing results would be the same, then there is a great potential that these two things wear the same plain text. Yet this is not really a sure thing because of the fact that there is this thing called salt key and salt hashing. So the same plain text would generate different hashes every time you hash them. So it's a really complicated matter, but it's off topic right now. It's off the scope of this video. So let us actually go ahead and try to implement this. But I think, I was thinking that this video is becoming too big, so I'm just going to stop the video right now, and I'm going to record a new video showing the practical implementation of this. Up till now, what we did was to just, let me just see this here. So up till now, we just created the structure, the node structure, and we created the hash function, which is really, really scalable and flexible. And I showed you the implementation. I think it was, this is the node structure. And I would say that the hashing itself is right here. This is the hash function. This is right here is the hash function. And so it takes the input and the length, it gets the modulo and returns the result. So I hope that you understood this. If you have any questions, leave them in the comment below. Do not forget to subscribe to the channel and share those videos. I need the world to understand that algorithms and data structures are not a pain in the neck. They are a beautiful thing, and they serve a better purpose, and everybody can understand it. So hopefully that you understand these concepts. They're very simple. Just leave any comments below. If you have any questions, leave the comment below. Do not forget to like the video, subscribe, and share, and hopefully we'll see each other the next video. Thank you, and take care.